Today we're going to be talking about putting fractions into simplest form. In order to understand what simplest form is, you have to understand what the word reduce means. When we reduce something, we make it smaller. When we're making a fraction smaller and reducing it, we're not changing the fractional representation. We're just making the actual numerator and denominator smaller numbers so that they're easier to work with. So we have to remember that we're going to be making an equivalent fraction. It's just going to have a smaller numerator and denominator than we started with. So when we do this, when we reduce a fraction by making an equivalent fraction with the smallest numerator and denominator possible, we call this simplest form. Simplest form is when you can only divide the numerator and the denominator by 1. There's nothing else that both of them are divisible by. And that's, once again, you have to have knowledge of your divisibility rules. So with this being said, in order to make a fraction in simplest form, we are going to be using the operation of division. I'm going to show you just some examples of fractions that are already in simplest form. Let's look at 1/2. The only thing I could divide both of these guys by is 1, because 1 is as small as it's going to get anyways. Another one is 3/4. I could divide 3 by 3, but I can't divide 4 by 3. The only thing that 3 and 4 are both divisible by is the number 1, so it's in simplest form. We're going to look at two different methods to find simplest form. The first one is kind of a guess and check strategy. And when I start to see things in fractions, I can start thinking about what I know both numbers are divisible by. But if I can't really figure something out, there's a little saying, when in doubt, try 2 out. And you'll see what this means in just a second. Alright, so let's look at this fraction, 16/32. I am going to pretend I don't know what both of them are divisible by, so I'm going to start by dividing them both by 2. That's that little saying, when in doubt, try 2 out. So I'm trying to make an equivalent fraction that's in simplest form. 16 divided by 2 is 8. 32 divided by 2 is 16. I'm looking at that and I see they're both even numbers, so I know that I'm not done dividing and trying to get to simplest form, because these are not just divisible by 1. I can divide them by 2 again. 8 divided by 2 is 4. 16 divided by 2 is 8. Once again, I say, oh, these are both even, so I know they're divisible by 2, so I'm not in simplest form yet. So I'm going to divide by 2 again. And I get 2/4. Once again, I sit there and say, well, still not where I need to be. I need to divide by 2 again, and I get 1/2. 1/2 is simplest form. My guess and check strategy sometimes takes me a little bit longer than the other method I'm going to show you, the other strategy. I could have said 16/32. If I have some number sense, I could have said, ooh, I know that 16 times 2 is 32, so I could have divided these by 16. Said 16 divided by 16 is 1, 32 divided by 16 is 2. So that's another guess and check strategy, but using a little bit of my number sense. So you can always do divide by 2 if it works. Sometimes it's going to be divide by 3. But you can also look for shortcuts with number sense. So that's your guess and check strategy. Now we're going to use the GCF strategy. If I had the fraction 30/40, I am going to find the factors of 30 and the factors of 40 using my prime factorization. So I know that 3 times 10 is 30. 3 is prime. Break 10 apart into 2 times 5. Both of those are prime. So my prime factorization is 2 times 3 times 5. Okay, so that's for 30. 40, I'm going to break apart into 4 times 10. 4 can be broken into 2 times 2. Both of those are prime. 10 can be broken into 2 times 5. Both of those are prime. So it's 2 times 2 times 2 times 5. Alright, now I'm going to compare the two of them. I've got 2 times 3 times 5 for 30. Then I have 2 times 2 times 2 times 5 for my 40. Now I'm looking for something I see in the top and the bottom. So I see both of them have a 2 and both of them have a 5. So 2 times 5 equals 10, and that's my GCF. So using my GCF, I know what to divide by without having to go through the 2 and the guess and check and all that. 30 divided by 10 is 3. 40 divided by 10 is 4. So 3/4 is 30/40ths in simplest form. A lot of us have to kind of do this to find the GCF. Some of us are going to start to see, start to use number sense and say, oh, I know 10 is going to go into both of those, and see if I get it. Now 3/4, the only thing I can divide both of them by is 1. So it is in simplest form. So we're going to practice a few more. We're going to use both strategies, the guess and check and the GCF. Alright, 22/44. I can sit there and say, okay, I know 2 is going to go into both of them, right? 2 goes into 22 11 times. 2 goes into 44 22 times. And then I can say, wait a minute, that can't be all that I can do, because I know 11 is divisible by 11, and so is 22. So 11 goes into 11 one time, 11 goes into 22 two times. So I did kind of a guess and check strategy for that, and I got 1/2, which is the simplest form. I could have done that same thing using my GCF. 22, I break into 2 times 11. 44, I'm going to break into 2 times 22. Forgot to put boxes around those because those are prime. Okay, there's 2. 22 breaks down into 2 times 11. Those are both prime. Now I have for 22, 2 times 11. For 44, I have 2 times 2 times 11. So I'm looking for similar ones in both prime factorizations. I see a 2 in both of them. I see 11 in both of them. So 2 times 11 equals 22. So my GCF is 22 on this one. So I could have just said 22/44 divided by 22, and I would have got 1/2. So either way, I'm still going to come up with the same simplest form, but sometimes when I can start seeing the GCF in my head with number sense, I can start doing this even faster instead of just guess and check and trying by 2s and 3s and 5s and so on.